Hello everyone, I am Aishwarya and I am here to present about ATM networks and its protocol architecture. ATM stands for Asynchronous Transfer Mode and it transmits broadband information which is of fixed length, which is relatively small. The size of ATM network cells is 53 bytes and it is suitable for carrying both constant rate data as well as variable rate data. Its network actually evolved from Broadband Integrated Services Digital Network. I'll be explaining about the protocol architecture and its functions. This is the protocol architecture of ATM network. It consists of a horizontal layers which indicate the encapsulation of protocols through level of abstraction. The vertical planes indicate the functions that require coordination of actions. So dividing the functions into control plane and user plane, and its advantage is the degree of independence in defining those functions. This is a format of ATM cell, and the one which is of the left side is a ATM cells at user network interface, and the one which is at the right side is the ATM cells at network node interface. So this consists of these ATM cell consists of a header and a payload. The header consists of these following elements, where the generic flow control, virtual path identifier, all these are the elements of the ATM header. The generic flow control between N systems and ATM network, the flow control is maintained by the generic flow control. It is a 4-bit field and it negotiates the multiplexing and flow control among the cells of various ATM connections. The virtual path identifier defines the virtual path for a particular cell. For permanent virtual circuit connections, it is manually configured, and for switched virtual circuit connection, they are found during connection setup. With a virtual path identifier length of 8 bits, 256 different virtual paths are allowed in the user network interface. This virtual path identifier is generally used for administrative purposes such as signaling for creating and deleting dynamic ATM connections. The virtual channel identifier, it is within the specified virtual path. Virtual channel identifier defines a virtual channel for a particular cell. Similar to virtual path identifiers, these virtual channel identifiers are also manually configured for permanent virtual circuits, and for switched virtual circuits, they are found during the connection setup. The next layer is the payload type identifier. It is a 3-bit field and its bits are used as follows. The first bit tells the type of ATM cell that will follow. If the first bit is 0, then it signifies that the user data, and if it is set to 1, then it signifies operations, administration and management data. The second bit is called explicit forward congestion indicator, and it helps in identifying whether the cell has congestion or not when it is sent from source to destination. Initially, the second bit is set to 0 by source, and when congestion occurs during routing of cell in a switch, the bit is set to 1. The last cell in the block is indicated by the third bit. The next one is cell loss priority. It is a 1-bit field and is used as a priority indicator. The cell has higher priority when the bit is set to 0, and hence the switcher should send this cell without any delay. When the bit is set to 1, during congestion situations, the switchers will remove the cell. The header error check is an 8-bit field which helps the ATM switch to correct the single bit error or to identify the multiple bit errors in the ATM header. It checks for only ATM header and leaves the payload. So the difference between the user network interface and the network node interface is cells at the network interface carry a data field for the flow control of data. Thus, in user network interface, only 8 bits are available for virtual path identifier, whereas the network node interface has 12 bits available for virtual path identifier. The virtual path identifier and the virtual channel identifier identify the virtual connections set up in ATM networks. They provide a hierarchy in the number of virtual connections. So I will be explaining about the different layers in the ATM cell. The first layer, the physical layer, it is subdivided into two layers: transmission convergence sublayer and physical medium sublayer. Transmission convergence sublayer, its functions are generating and receiving cells, generating and verifying the cyclic redundancy check in the header error control field. This field works in this way. These ATM cells are transmitted as a continuous stream of bits. If the receiver knows the start of first cell, the next cell starts at multiples of 53, since the size of ATM cell is 53. But the problem here is the identification of the first cell. Hence, a cyclic redundancy check code is inserted in the header error control field in each ATM cell by the sending device. On each 40 consecutive bits of the bit stream, the receiving device performs cyclic redundancy check. Thus, only valid headers will pass this test. And the physical medium sublayer, its function is associated with transmission of bits over specific physical medium. Usually, the transmission layer is optical fiber. The next layer is ATM layer. The main function of ATM layer is routing and switching of ATM cells. This ATM layer recognizes the following service categories: constant bit data, which is a constant data rate is allocated and it is available for the duration of connection. Real-time variable bit rate. There are some commitments about the data rate to be made available. The delay and variation in delay are tightly controlled in real-time variable bitrate. Non-real-time variable bitrate. There are some commitments about the data rate to be made available, but the difference between the real-time and non-real-time is there are no delay limits placed on the delivery of cells in non-real-time variable bitrate. Unspecified bitrate. There are no commitments about the data rate to be made available in unspecified bitrate. Available bitrate. The data rate made available may be changed during the time a connection is maintained. Guaranteed frame rate. There is a commitment about the minimum data rate of a connection. The next layer is ATM adaptation layer. This layer accommodates the packets sent from the upper layers. It is again subdivided into two layers: convergence sublayer and segmentation and reassembly sublayer. The convergence sublayer provides services to higher layers through a set of protocols. Segmentation and reassembly sublayer, it separates the message from the convergence sublayer into ATM cells. These two sublayers add the protocol information which is transported in the payload of ATM cell. The function of ATM adaptation layer, as I told earlier, is to accommodate the packets sent from the upper layers of the ATM cell. Based on the different protocols, there are different protocols defined for ATM adaptation layer. Their timing relationship, it is based on the synchronization between sender and receiver. Bitrate is based on being constant or variable. Connection mode, it is based on connection oriented or connectionless. These parameters are linked with the forum classes, which are class A, which uses a constant bitrate, class B, which uses a variable bitrate, class C, which uses available bitrate, and class D, which uses unspecified bitrate. So depending on these relationships, the ATM adaptation layers has different types, and it is divided into type 0, type 1, type 2, type 3, type 4 and type 5. The type 0 is not an official type, but it is just referred for wholeness. Type 1, as I mentioned earlier, it uses class A and it performs the functions such as segmentation and reassembly of user information, dealing with cell delay variation, dealing with cell reassembly variation, dealing with lost cells, recovering source clock frequency at the receiver, recovering source data structure at receiver, checking and correcting bit errors in user information field. Type 2, this uses class B and it has the same functions as that of type A. Type 1, the additional functions of this type 2 is notifying the higher layers regarding errors and transferring timing information between source and destination. Type 3 and 4 are combined together and they support both class C and class D services. In this type, the convergence sublayer is divided into two types: service specific convergence sublayer, common part convergence sublayer. So this works in two modes of operation: message mode and streaming mode. Message mode. The message mode is responsible for using frame data where the service data unit is a logical data and it is transported in one or more of the PDUs, and this is further divided into many service data units. In the streaming mode, these PDUs are fixed size and are resent in single CS PDUs, and these are rendered in separate segmentation and reassembly layer. The type 5 also provides the same services as that of the type 3 and 4, but the advantage is that it has a reduced overhead and minimizes the protocol processing. By moving the protocol information in segmentation reassembly to PDUs, this is done. It is used by variable bit data resources. So, and these are the references I have used. Thank you.